In the tech industry, the ultimate flex is definitely that big flip the switch global rollout.
Oh, yeah,
Eh,
absolutely. Everyone loves that moment.
Right. I mean, you've probably seen it, or maybe you've even been a part of one. A company builds this massive, supposedly revolutionary new system.
And they get everyone into a war room.
Exactly, yeah.
Yeah.
Someone dramatically hits the enter key and they just upgrade thousands of interconnected systems at the exact same moment.
And then the metrics board lights up and everyone cheers.
Yeah, we just crave that grand reveal. I mean, we're so deeply conditioned to believe that if a solution is truly powerful, well, it should just instantly conquer the entire landscape.
Right. It should just work everywhere all at once.
But today, we're looking at an engineering strategy that argues doing exactly that. I mean, flipping the master switch on a complex network is actually a recipe for total diagnostic disaster.
It really is.
Uh,
What we're looking at today is just a master class in extreme, almost painful restraint.
Welcome to the deep dive. So today, we are opening up a really highly detailed, incredibly rigorous engineering strategy document. It's known simply as Ultraplan 8, or UP8 for short.
It's a fascinating read.
It really is. And our mission today is to unpack the exact mechanics of establishing what this document calls a golden delivery baseline.
Right. So we're looking at a system named AMOS.
Yeah, AMOF, which is this highly advanced automated delivery engine. But the crazy part is how the engineers behind it deliberately chose to restrict its power.
They basically bottle it up.
Exactly. They bottle it up and prove it against a single isolated target before ever letting it touch the rest of the fleet.
And I think the central tension of Ultraplan 8 is this methodical rejection of that flashy simultaneous rollout we just talked about.
Yeah, it fundamentally challenges our impatience.
It does. When you have a shiny new tool, the impulse is always to use it everywhere immediately. But this document proves that scaling a process before you've mathematically proven it works in isolation, well, doesn't mean you achieve success at scale. It means you fail at scale. And you do so with such complexity that you can't even diagnose why it broke.
Which is terrifying. And honestly, this mental model is profoundly applicable to you listening right now, regardless of what you do for a living.
Absolutely.
I mean, if you manage complex personal workflows, or if you coordinate logistics, or even if you're just attempting to automate a basic business process, this framework is invaluable.
It's a blueprint for how to demand hard receipts from your systems.
Yeah.
It teaches you how to map the messy hidden truth of your current state before you trust a new solution with your critical infrastructure.
So let's dive straight into the first segment. The document actually doesn't waste any time with pleasantries.
No, it gets right to it.
Yeah, it kicks off with a section titled The Executive Verdict, and it lays down this unbending rule right away. It says Ultraplan 8 must start with exactly one golden downstream ecosystem.
Just one.
Just one. And out of all the applications they could have chosen, they select one named GMD.
Right, GMD.
And it explicitly states that the core automation platform itself, which is named a NEMPF platform, has to remain strictly isolated as the delivery plane under test.
It orchestrates the deployment. It's not being deployed.
Right. So to truly grasp the weight of that executive verdict, we have to look at a foundational rule recorded in the document.
Yeah, the authors write that edited code, runtime code, and deployed code must be in the exact same lane.
The exact same lane.
It is a non-negotiable structural requirement. If those lanes blur or cross, then every single subsequent proof of delivery is just inherently corrupted.
Okay, I want to visualize that because it sounds a bit abstract. When you say edited code, runtime code, and deployed code must be in the exact same lane, what does that actually look like mechanically? Like, what happens if they aren't?
Okay, so think about the life cycle of a software application. A developer sits at their laptop and types out a new feature.
Right.
That is the edited code. Then they hit save, and they spin up a local server right there on their machine to test it.
Okay, so that's the runtime code.
Exactly. And finally, they push a button to send that code to a public cloud server so customers can actually use it. And that is the deployed code.
Makes sense.
Now imagine a scenario where the developer's laptop has a very specific hidden configuration file installed on it.
Uh-oh.
Right. So the runtime code on their laptop uses that file, and everything works perfectly. But when they push it to the deployed environment, that hidden file doesn't exist on the cloud server.
So the lanes have crossed. The environment where the code was edited and run locally is materially different from the environment where it's actually deployed.
Precisely. And when it inevitably breaks in the cloud, you are left chasing ghosts. You spend hours looking at the code itself, assuming you wrote a bad function.
When really the code is totally fine.
Right, the environment is what failed you. If you don't force all three of those stages into the exact same lane, meaning they're utilizing identical, universally verifiable configurations, you don't actually know what you're testing.
Wow, yeah.
Yeah.
You might get a successful deployment, but it could just be because a leftover manual tweak from 3 months ago happened to act as a crutch.
Exactly.
Yeah.
You have zero structural integrity.
Okay, so keeping the lanes identical makes perfect sense for reliability. But I kind of want to play devil's advocate here regarding that one ecosystem rule.
Okay, go for it.
Let's say I'm a senior stakeholder looking at Ultraplan 8, and I've just spent a massive amount of capital funding this whole AMOF system.
Right, it's a big investment.
It's supposed to be the state-of-the-art orchestration tool capable of managing an entire fleet of applications. So I would naturally assume a massive fleet rollout is the ultimate test.
That's what people usually think, yeah.
Right, so is the reluctance to do a fleet rollout just a fear of server overload? Like, are they worried about pushing too much data through the network pipes all at once?
No, not at all. I mean, network bandwidth is rarely the bottleneck in modern cloud infrastructure. The authors of Ultraplan 8 aren't worried about data pipes bursting. They're worried about something much more insidious: diagnostic blindness. The text explicitly outlines why doing it all at once is a disastrous trap. If you attempt a simultaneous fleet rollout, you are forcing the system to solve three entirely distinct, highly complex problems at the exact same millisecond.
Okay, let's break those three problems down. What is the automation actually fighting against in a big fleet rollout?
Well, problem number one is you are testing the AMO control plane itself.
Because it's brand new.
Right. This is a brand new automation engine. Does it even function correctly? Does it read the instructions properly? We don't know yet.
Okay.
Then problem number two, you are testing actual downstream app delivery. Can this system successfully package, route, and deploy a standard application to a target environment?
Right, the actual job it was built for.
Exactly. And then problem number three, and this is the absolute killer, you are dealing with legacy ecosystem cleanup.
Ah, the ghosts in the machine.
The ghosts, the cobwebs, the rusted gears, all of it. You are forcing the new system to navigate all the undocumented quirks and broken dependencies of older, poorly maintained applications.
So if I flip the master switch and the deployment fails, I have a totally catastrophic muddy water situation.
You completely lose the ability to attribute failure. Let's say you hit that giant enter key on a Tuesday afternoon and red lights just start flashing everywhere.
Deployments are failing across the board.
Right. Did the core AMOF delivery mechanism break? Does standard application have a typo in its source code? Or did the automation simply trip over a retired piece of legacy code in an obscure app that still relies on an IP address from 2022?
You just simply do not know.
You don't know. You would spend days or maybe even weeks debugging the brand new AMOF engine and rewriting its core logic.
Only to eventually realize the engine was perfectly fine all along.
Exactly. The failure was caused by some corrupted, forgotten text file buried deep inside one of the legacy apps you tried to drag into the future.
Man, you've just described the nightmare scenario that Ultraplan 8 was written to prevent.
It really is a nightmare. By testing everything at once, you completely destroy your ability to isolate the variable.
Right.
And the text points out that a fleet rollout hides whether your baseline delivery logic is even sound, because different applications have entirely different readiness levels for modern infrastructure protocols.
Things like DNS routing or GitOps methodologies. Right.
Exactly.
Actually, stop right there. Let's make sure we define the mechanics for everyone. When the document references GitOps methodologies, what does that actually mean in the context of keeping these systems perfectly aligned?
Okay, so at its core, GitOps is a practice where a version control system, typically Git role, becomes the absolute single source of truth for both your software application code and your infrastructure declarations.
Okay.
In the old days, an operator might SSH into a live server and manually tweak a firewall rule or adjust memory allocation.
Right, just logging in and typing commands.
Yeah, but with GitOps, manual intervention on the server is strictly forbidden. If you want to change the memory allocation, you write a text file describing that change, you commit it to a central repository, and an automated agent sitting inside the server reads that file and configures itself to match.
Okay, so the repository is the law, and the server just obeys whatever the repository says.
Exactly. But if you do a fleet rollout, some of your legacy apps might not be compatible with GitOps yet. They might still require those old manual tweaks.
Oh, I see.
So your AMO system, which expects pure GitOps obedience, suddenly hits a brick wall trying to deliver an app that demands a manual handshake.
That makes total sense.
And furthermore, if you force a fleet-wide upgrade, you face a terrifying dilemma regarding existing developer workspaces, what the document calls ticket work trees.
What's the dilemma there?
Well, if you treat all those scattered developer workspaces as sacred, you end up preserving all the chaotic, accidental drift that developers naturally accumulate on their machines.
You just import the chaos into your brand new system.
Right. But on the other hand, if you treat all those workspaces as disposable and just wipe them clean to force the upgrade, you run the very real risk of accidentally deleting unique, highly valuable receipts of past work that just haven't been centrally saved yet.
It's a complete lose-lose scenario. The fleet rollout isn't just risky, it actively destroys your ability to observe the objective truth of your own architecture.
Which is exactly why the authors of Ultraplan 8 engineered a strictly sequenced, highly disciplined 7-wave approach. You do not get to touch the delivery engine until you have proven you understand the landscape.
And that imperative to understand the landscape forces us right into what the document calls wave zero. And I have to say, the terminology here is just brilliant. They call it truth pre-flight.
It's a great name.
It is. I mean, before a single line of code is moved, before any system is restarted or tested, the protocol demands an absolute comprehensive inventory of the current state of the world.
And the phrasing truth pre-flight is very intentional. It elevates the task from just a basic system check to an existential requirement.
Right.
The system demands an inventory of every manifest-backed ecosystem, and it specifically lists an ARF platform GMD, hotshot, and demo microservices.
Okay, let's clarify manifest-backed ecosystem really quickly so we aren't leaving anyone behind.
Sure. A manifest is simply a declarative configuration file. It's a document that says, here is exactly how this application should look, what resources it needs, and how it should behave.
Okay.
So a manifest-backed ecosystem is an environment where the entire architecture is generated from these text files, rather than from someone clicking through a graphical user interface to build servers one by one. It's infrastructure as code.
Got it. So wave zero requires us to find the quote-unquote truth of all these manifest-backed ecosystems, but they aren't just looking for a simple list of file names, are they?
No, not at all.
The authors break this down into specific, incredibly demanding dimensions of truth. And honestly, reading through this list made me realize just how terrifyingly fragile modern software ecosystems really are. Let's walk through these dimensions.
It is a daunting audit for sure. Let's begin with repo truth. You must document the manifest repository list, the exact branch that is checked out, the remote URL, and crucially, what they call the dirty state.
The dirty state. I assume that means local drift. Like an engineer was testing something late on a Friday, changed a few lines of code to make it work, but then just never committed those changes back to the central repository.
That is exactly what it means. If you don't document that a machine is in a dirty state, and you ask an automation engine to pull the code from that machine, well, it might pull the uncommitted Friday night hack instead of the official software.
And you have completely lost control of the source truth.
Exactly.
Okay, what's the next dimension?
Environment truth. You need to know the declared provisioner. What tools actually build the servers? What are the designated target environments, development, staging, production? And vitally, where is the Argo or Helm source of truth?
Okay, Argo and Helm. More industry standard tools we should quickly define. I know Argo CD is a continuous delivery tool used heavily in Kubernetes environments.
Right.
It essentially sits inside your cluster, looks at that Git repository we talked about earlier, and says, does my current reality match the text files in the repository?
And if not, it forces reality to match the text.
Right. So what about Helm?
Helm acts as a package manager for Kubernetes. Think of it like the App Store for your server cluster. It bundles up all those complex YAML configuration files into a single deployable package called a chart.
Oh.
So finding the Helm source of truth means locating the exact canonical package definition that Argo is supposed to be deploying. If you don't know where that is, you cannot safely orchestrate an update.
You're just flying totally blind. Okay, so we have repo truth and environment truth. What follows?
Release truth. What is the current version of Amof running right now? Where are the release logs? Where are the audit records? And most importantly, does the declared release status actually agree with what is physically running live?
Man, that is such a common trap. The dashboard says, congratulations, version 2.0 is deployed and healthy.
But is it really?
Right, because if you actually dig into the server, maybe it failed silently halfway through and the system is still running version 1.9. If you assume the dashboard is telling the truth without verifying the runtime reality, your entire baseline is built on a lie.
Precisely. Which leads directly into the next requirement, which is DNS truth. This is how the outside world actually finds your application.
Right, routing.
Yeah, you must audit the intended host names. You must verify what the Cloudflare routing records actually say.
Hmm.
What is the status of the TLS security certificates? Are they about to expire? Are the live HTTP health endpoints actually returning a successful response?
I can easily see how DNS truth causes absolute chaos. Let's say a developer named, I don't know, let's call him Dave.
Okay, Dave.
Let's say Dave manually logs into the Cloudflare dashboard to temporarily route traffic around a down server. He fixes the server, but he gets distracted and completely forgets to change the Cloudflare rule back.
It happens all the time.
Right, and then months later, Amof tries to deploy a perfect update. It installs the code flawlessly on the correct server. But because Dave's hidden forgotten Cloudflare rule is still active, all the user traffic is being redirected to a dead backup server.
Exactly. The deployment was mathematically perfect, but from the user's perspective, the website is completely broken.
That is a brilliant example of why DNS truth is paramount. I mean, it doesn't matter if your code is pristine if your routing is pointing into a black hole.
It really doesn't.
Yeah.
And that brings us to a highly sensitive dimension: secret and config truth. We are talking about required environment variables, Kubernetes secrets, and local dependencies.
Let's unpack Kubernetes secrets because the word secret sounds very dramatic, but it's really a specific mechanical component.
Yeah, a Kubernetes secret is essentially a highly secure digital vault stored within the cluster. Applications need passwords to connect to databases. They need API keys to talk to third-party payment processors.
And you absolutely cannot hard code those passwords into your source code where anyone can read them.
Right, so you store them in this digital vault. The application is programmed to reach into the vault, grab the key when it starts up, and use it in memory.
So if you are executing a massive system upgrade and you accidentally overwrite or delete that digital vault because you didn't inventory it properly during wave 0,
The application boots up, reaches into an empty vault, fails to connect to the database, and crashes instantly. Your system is down, and recovering those lost keys could be a monumental disaster.
wow.
And finally, the text mandates capturing build backend truth. Where is the code actually being compiled? Is it building locally on a developer's laptop? Is it building on a dedicated server cluster? What is the designated image registry where the final compiled application containers are stored?
The sheer volume of hidden state required to just define reality is staggering. And honestly, reading through this overwhelming checklist, I find myself thinking what a lot of impatient engineers would probably think.
Which is, why are we doing this?
Exactly. Why are we going to all this agonizing trouble documenting the messy, chaotic old state of affairs? I mean, if the goal of Ultraplan 8 is to build a pristine, brand new golden baseline using this incredibly powerful Amof automation, why not just rent a digital dumpster?
Just throw it all out.
Yeah, execute a massive scorched earth hard reset. Wipe the servers clean, delete the messy local developable branches, and start completely fresh from the master repository. Wouldn't a clean slate be infinitely faster than cataloging every single birdie file and mismatched DNS record?
It is the most tempting shortcut in the world of systems architecture.
Right, it sounds so clean.
It would absolutely be faster in the first 24 hours, and it would be an unmitigated catastrophe by the end of the week.
Okay, why?
This is where Ultraplan 8 introduces what I consider to be its most profound psychological and operational safeguard. It's the rigorous reset safety framework. The document explicitly and aggressively forbids blindly hard resetting a workspace simply because it is dirty or inconvenient to sort through.
I think that the text literally says never hard reset because a work tree looks old.
It does say that.
Okay.
And the reason is deeply tied to human behavior and change management. Local drift, which is the messy differences between what's on a developer's machine and what is stored in the central repository. It isn't just random junk.
Okay, what is it then?
Drift is a fossil record of human problem solving.
Oh, wow.
Yeah, when a system is rigid, humans actually create hidden workarounds to get their jobs done. If you just nuke the workspace from orbit, you aren't just deleting old code, you are destroying load-bearing, undocumented solutions that are secretly keeping the company running.
That makes total sense. It's like deciding to clean out a really messy garage by just backing a dump truck up to the door and throwing every single item away.
Right.
Sure, the garage is clean now, you have a blank slate. But 2 weeks later, a pipe bursts in the house and you realize you threw away the specialized wrench you needed to turn off the water main. You deleted the valuable tools along with the actual garbage.
That is the exact mechanical risk of a blind hard reset. To prevent this, the authors engineered a classification system for local drift. They created highly specific decision classes to force operators to categorize the mess before they're allowed to clean it up.
Okay, let's break down these decision classes,
Huh.
because this proves it isn't just a binary choice between keep everything or delete everything.
No, not at all. The lowest states category is reset safe. This applies to local code that perfectly matches the remote repository, or a workspace that only contains automatically generated residue like compiled temporary files that the system can instantly recreate.
Okay.
If a workspace is classified as reset safe, you can confidently wipe it. It is just dust in the garage.
Clean it up, no harm done.
Exactly. Then we encounter the crucial class, which is replay now. This describes local drift that actually contains critical bug fixes or configurations that are actively blocking the golden proof you're trying to execute.
Wait, so if you delete this code, your test will fail because you deleted the solution.
Yes.
So replay now means this code is messy, it's undocumented, but it's vital. We must intentionally salvage it, apply it to the canonical source of truth, and then we can clean up the workspace.
Exactly. You elevate the hidden workaround into official policy.
Brilliant.
The next class is replay later. This is real, valuable functional code that an engineer has written, but it has absolutely nothing to do with the specific golden baseline proof we are orchestrating right now.
Ah, so if you hard reset the machine, you destroy days of their labor.
Exactly.
That feels like a masterclass in respecting your team's labor. You don't just trash an engineer's side project just because you were running a major infrastructure test. You preserve a receipt of their work, you set it aside safely, and you leave it out of the current test parameters.
It requires immense operational empathy.
For sure.
Moving down the list,
Yeah.
hit the kill class. This is genuinely useless residue. Stale-proof screenshots from tests ran 3 years ago, entirely empty work trees or retired application states that offer zero delivery value.
This is the actual garbage in the garage.
Yes, you classify it as kill and you confidently delete it.
Burn it to the ground.
Exactly. And finally, the most critical and restrictive class, do not reset. These are the vaults. These workspaces contain unbacked up secrets, protected customer data, or mysterious changes touching deeply guardrailed network paths.
So hands off, basically.
Totally hands-off. You do not touch, move, or reset these files until they have been meticulously manually reviewed by a human being who understands the context.
So the barrier to exit Wave 0 is incredibly high. Every single checkout, every ticket worktree across the entire architecture must have one of these classifications legally applied to it.
It's an exhaustive process.
And only once this exhaustive pre-flight is complete and the entire hidden state of the system is mapped out without destroying any concealed value, can the engineering team confidently move to the next stage.
Right, and that transition moves us away from mapping the past and into deciding the future. Proceeding to Wave 1 means it is time to crown the champion ecosystem.
This is where Ultraplan 8 gets highly analytical, almost like a tournament bracket. Wave 1 is dedicated entirely to selecting the single golden ecosystem. Out of all the applications they mapped in Wave 0, they evaluate 4 specific contenders: IAM Platform, GMD, Hotshot, and Demo Microsoft.
And only one of these can be the first application pushed through the new Amof delivery pipeline.
And the document doesn't just guess right.
No, it relies on a rational elimination matrix to filter these contenders based on repository presence, infrastructure, chaos, live-proof chances, and reset risk.
I want to look closely at why 3 of these contenders completely failed the matrix. It's really revealing about what makes a system actually testable. Let's start with the app named Demo Microsoft. Why did it get cut?
Demo Microsoft is disqualified almost instantly. The text explains that it is a retired seed ecosystem. And the fatal mechanical flaw is that it relies on unreliable legacy local file URLs instead of proper remote Git repositories.
Let's explain why that's a fatal flaw mechanically. If the Amof automation is looking for the code, what is it actually experiencing when it hits a local file URL?
Well, a modern delivery engine expects to reach out to a standard centralized web address, like a GitHub repository URL, to pull the official version of the code. That URL is universally accessible to any server in the network.
Right.
But Demo Microsoft is hard-coded to look for a path on a specific hard drive, something like C:/document/project files.
Oh, I see.
If Amof is running on a cloud server, and the code tells it to look in a local C drive that doesn't exist in the cloud, the automation just hits a dead end. Because of this, its live-proof chances are near zero, and its reset risk is massive. The document explicitly relegates it to a recovery-only status.
Right. You wouldn't test a revolutionary new high-speed magnetic train on a crumbling wooden rail track from the 1800s. It proves absolutely nothing about the train.
That's a great way to look at it.
Okay, what about Hotshot? The name alone implies it's a fast, modern, high-performance application. Why not test the system on that?
Hotshot actually scores very high on repository completeness. It's a modern app.
Yeah.
But it fails the matrix because it's too risky for a first test.
Why is it risky?
The source notes that Hotshot is a production-oriented site. It is entangled with strict live environment guardrails. Specifically, the text highlights that it contains highly sensitive server.nv files and local commentary data.
For the listener, a .nv file or environment file is where you store the absolute most critical sensitive variables an app needs to run. It's where you put the master database passwords, the live API keys for the payment gateways.
Right, the keys to the kingdom.
Exactly. If you accidentally corrupt a .n file during a test, you aren't just breaking a testing environment. You could accidentally sever the application's connection to the real-world database.
Exactly. Because of those sensitive guardrails, Hotshot's reset safety protocol is incredibly strict. You can't just easily tear it down and rebuild it over and over again while you tweak the Amof delivery engine.
It's just too dangerous.
Right. It is a fantastic candidate for later in the rollout, but it's way too delicate and dangerous for the very first golden proof.
Okay, so that leaves a .f platform itself. It is the core delivery engine, the system they are trying to prove. If you want to prove your delivery system works perfectly, what better way than having it deploy its own updates? Why not use the system to deliver the system?
That is the ultimate architectural trap, and the document explicitly and forcefully warns against it. If you use the delivery plane to deliver the delivery plane, you trigger a massive inescapable bootstrap and debug confusion.
Previously, I've heard this described as a snake eating its own tail, but that's a bit of a cliche and doesn't really explain the mechanics. So how does this bootstrap confusion actually manifest in the real world?
Okay, think of it like this. Imagine you have a highly complex robotic arm inside a factory. Its only job is to build identical copies of itself.
Okay.
You program the master robotic arm, you turn it on, and it starts building a new arm. At the very end of the process, a vital screw on the new arm is loose, and the new arm just falls apart.
Yikes.
Now you have a massive diagnostic problem. Did the new arm fall apart because the digital blueprint you fed into the master arm was flawed? Or did the new arm fall apart because the physical wrench attached to the master arm was broken?
You don't know if the instruction was wrong or if the mechanism executing the instruction was broken.
Exactly. You completely lose your objective observer. If Amof fails to deploy Amof, you have no external vantage point to tell you if the code was bad or if the delivery engine was broken.
That is a brilliant analogy.
You must force the delivery plane to stand apart from the workload it is delivering so it can report on the success or failure with absolute uncorrupted objectivity.
Which leaves us with the sole survivor of the matrix, the application named GMD. The document officially crowns GM as the perfect first target. Mechanically, what makes it the ideal test subject?
The source outlines a beautiful alignment of factors. First, GMD is officially documented as the canonical example application ecosystem. It was built to be the standard template.
Nice.
Second, it is highly constrained. It has exactly one writable application repository, which keeps the scope of proving the source control and the build engine incredibly narrow.
It's a small, predictable surface area.
Yes. Third, because it's a separate application, it completely avoids the robotic arm bootstrap confusion we just talked about.
Right.
And finally, perhaps most importantly, GMD already maps perfectly to a universal Argo CD delivery pattern. It isn't a mess of random servers. It already has cleanly structured, isolated environments for GMD development, GMD testing, and GMD production. It is a perfectly predictable framework.
I love the logic behind this elimination. It reminds me of designing a massive automated global postal logistics network.
Oh yeah, how so?
Well, if you were trying to prove that your new barcode scanners, conveyor belts, and routing algorithms work flawlessly, you do not test the system by trying to mail the post office headquarters building itself through the mail.
Right, that's the Amof platform bootstrap confusion.
Exactly. And you don't test it by attempting to mail a highly classified, incredibly fragile glass sculpture wrapped in 1,000 layers of red tape.
That's Hotshot with its sensitive production secrets.
Yes. And you absolutely don't test it by trying to deliver a crumbling water-damaged letter from 1985 with half the address rubbed off.
That's the retired demo micro sauce. That is an incredibly accurate mapping of the matrix.
You test your revolutionary new logistics network with a completely standard, perfectly formatted trackable parcel, a medium-sized cardboard box, a clear, high-contrast label standard weight, that is GMD.
Right?
It is the ideal test subject precisely because it is boring. It allows the engineers to evaluate the mechanism of delivery itself without constantly worrying about the unique, erratic quirks of the cargo.
The boring predictability of the cargo is exactly what allows you to relentlessly test the vehicle.
Okay, so now that the target vehicle GMD is locked in, we encounter a crucial problem. The Amof system needs a watertight set of instructions to actually execute the delivery. You cannot just casually ask the system to do it. You need a rigid framework of communication.
And this brings us directly to Wave 2.
Right, Wave 2 introduces the strict JSON director delivery contract. Here's where Ultraplan 8 makes a fascinating, fiercely stubborn technological choice. We are living in an era utterly obsessed with artificial intelligence and conversational interfaces.
Oh, absolutely everything is a chatbot now.
Yeah, the current industry trend is entirely focused on natural language processing. The idea that you should just be able to type, hey, AI, deploy the new update to the testing server, and the system is smart enough to figure out the missing pieces.
But this document explicitly and vehemently kills the conversational prompt.
It does. It states verbatim this is not a conversational prompt format. It demands an incredibly strict, structured JSON execution envelope.
It represents a profound philosophical shift in how these engineers view their relationship with automated orchestration. The system they are referencing, the director, is not designed to be a chatty, helpful assistant.
Right.
It is a mathematical engine that requires an unyielding, legally binding contract to function.
Let's dive deeply into what is actually required in this JSON contract, because this isn't just a simple command. The document dictates that the operator must explicitly define fields, including ecosystem, ticket, EID, goal scope constraints, target environment, build mode, deploy mode, release intent, and acceptance criteria.
Every single one of those fields acts as a mechanical guardrail. You aren't just saying deploy the code, you are defining the exact boundaries of reality the system is allowed to operate within.
I want to look at how 3 of those fields function mechanically, because reciting a list of JSON keys doesn't do justice to how powerful this is. Let's look at constraints, release intent, and acceptance criteria. Let's say I'm an operator filling out this contract. How do constraints physically alter the behavior of the Amof automation?
Well, if you are relying on a conversational AI and it encounters a memory limit during a build process, it might automatically decide to spin up a larger, much more expensive cloud server to finish the job because its primary goal is just to complete the task.
It wants to be helpful.
Exactly. It wants to be helpful, but in a baseline proof that helpfulness corrupts the test. By defining strict constraints in the JSON, for example, maximum memory allocation is 4 gigabytes. If exceeded, terminate immediately. You mechanically strip the system of its ability to improvise.
So it must fail exactly within the parameters you defined.
Exactly.
Okay, what about release intent? Why does the system care about my intentions? Isn't code just code?
Release intent forces the operator to declare why this mutation is happening. Is this a minor bug fix? Is it a massive database migration? Is it a security patch?
Okay.
By forcing the contract to include the intent, the director can cross-reference the action against predefined safety protocols. If the release intent is flagged as minor cosmetic update, but the payload contains a command to drop a production database table, the director identifies the logical mismatch between intent and action and mechanically blocks the execution before a single line of code is moved.
It's an automated sanity check. That is brilliant. And finally, acceptance criteria. How does this differ from just saying make sure it deploys successfully?
Well, deploy successfully is a subjective conversational phrase. The machine doesn't know what that means. Acceptance criteria forces you to define binary mathematical proof.
Okay, like what?
It forces you to write the deployment is only successful if HTTP endpoint/health returns a 200 OK status code within 45 seconds of Argo synchronization. It leaves zero room for interpretation.
But I have to push back here, again, channeling the modern tech mindset. Why revert to this extreme rigidity? If the AMOF system is advanced enough to handle all this orchestration, why not build it to be fluid? Why not let it intelligently bridge the gaps? Isn't extreme rigidity a step backward?
In the context of establishing a golden baseline, fluidity is the absolute enemy of proof.
Okay.
The moment a system becomes fluid, it begins making assumptions. If a variable is missing, it guesses based on historical data. And the second an automated system guesses, you no longer possess a reproducible, reliable proof of concept.
You just have a lucky accident that you can never guarantee will happen the exact same way twice.
Exactly. Fluidity is the enemy of proof.
That is a fantastic summation. The structured JSON contract ensures that the director logically validates every single variable before it begins execution. It runs without ambiguity.
And crucially, it summarizes the final result with brutal objectivity.
Right, and the text places enormous emphasis on how the contract handles failure, drawing a massive uncrossable line between two specific failure states, fail versus blocked.
Yeah, to a frustrated user sitting at a keyboard, a failure is just a failure. The screen is red, the app didn't deploy, they don't care why.
Right, they just want it fixed.
But to the automated director analyzing the JSON contract, the distinction between fail and blocked is the most important diagnostic signal in the entire system.
Let's define the mechanical difference. What constitutes a fail?
The document defines a fail as a scenario where the JSON contract was fully executable. The operator provided all the required inputs, the system had the correct network access, it possessed the necessary security keys.
Okay, so it had everything it needed.
Right, it attempted the build, it attempted the deployment, but one of the explicitly defined acceptance criteria we just talked about was missed.
Like the health check failed.
Exactly. The code successfully pushed to the server, but the health check endpoint returned a 500 server error instead of a 200 error.
So a fail means I had all the tools, I followed the instructions perfectly, but the payload itself was defective.
Exactly. It's a failure of the software being delivered.
Okay, what about blocked?
Blocked, on the other hand, means an external prerequisite prevented the execution from even beginning. The director attempted to start, but realized a foundational element was missing. This would be a missing DNS credential, a corrupted kubeconfig file, or a required build backend being offline.
So to use a simple analogy, if I ask you to solve a complex math equation, a fail means I handed you a working calculator. You typed in all the numbers, but you wrote down the wrong answer.
Right.
A blocked means I asked you to solve the equation, but I locked the calculator in a safe and refused to give you the combination. You couldn't even attempt the math.
Perfectly stated. The failure states tell the engineers exactly where to look for the broken piece. And this brings us to the most unyielding rule embedded in this entire contract structure. The director must not continue to release or promote code if a single step fails or is blocked. It must halt immediately, dead in its tracks.
So the document strictly forbids any patching it on the fly.
Yes.
Meaning, if the deployment fails at step 4 out of 10, an engineer isn't allowed to jump into the terminal, manually tweak a setting to force step 4 to pass and let the automation resume step 5?
There are absolutely no heroic interventions allowed, because the moment a human jumps in to patch a failing step, the golden proof is fundamentally corrupted. You can no longer claim that Amof delivered the application.
You must admit that Amof and a panicked engineer delivered the application.
Which entirely defeats the purpose of the test.
So with this flawless, totally unyielding JSON blueprint acting as the ultimate authority, Ultraplan 8 transitions into Wave 3. This is the crucible. Wave 3 is where the blueprint is actually used to build the building, but it demands explicit, verifiable receipts at every single door it passes through.
Wave 3 is titled The Golden Ecosystem End-to-End Proof. It outlines a highly specific, totally rigid 8-step flow that must be executed in exact sequential order.
Let's walk through this 8-step gauntlet. Step 1, fresh baseline. The system must capture the absolute current state of everything manifests DNS routing Argo synchronization state before a single mutation is authorized.
Right.
Step 2, new ticket. Create a dedicated isolated tracking ticket scoped only to the specific GMD proof.
Keep it contained.
Step 3, build. The system compiles the code. Step 4, deploy via Argo. Step 5, Cloudflare DNS and live verification. Step 6, release bump, which generates the actual patch receipt. Step 7, promote to the final target environment. And finally, Step 8, final readback, where the director returns the completed JSON contract summarizing the results.
It is a totally comprehensive, hermetically sealed lifecycle. But I want to draw our attention to a specific, absolutely vital mandate buried within Step 3, the build phase.
Yes, this is where the paranoia of the document really shines through. The text explicitly dictates that the build process must run from explicit commit evidence, not ambient checkout state.
That phrase is so important.
When I first read the phrase ambient checkout state, it sounded so dramatic. Why is this engineering strategy so absolutely terrified of an ambient environment?
Because ambient state is the silent killer of reproducible software. Ambient state refers to whatever hidden undocumented variables happen to be sitting on a specific machine at the exact millisecond the build command is executed.
It is the absolute definition of the classic engineering. Well, it compiled perfectly on my laptop.
Right, and it compiled on their laptop because of some invisible ambient factor.
Let me give you a mechanical example of how ambient state destroys a deployment. Imagine an engineer is building a web application that relies on a very specific custom typography font. They install the font files deep in the operating system of their local laptop. When they run the code locally, the application looks around, finds the ambient font files on the hard drive, and renders perfectly.
So the engineer thinks the code is flawless.
Right. They tell the Amof system to build from their ambient checkout state.
Yeah.
The system complies. But when the application is deployed to a sterile cloud server, the custom font files don't exist there.
And the application crashes upon startup because it is looking for a dependency that only existed in the engineer's local ambient environment.
The code was relying on a ghost.
Exactly. And if you allow AMOF to build from that ambient state, even if the build temporarily succeeds, you can never reproduce it because that exact arrangement of local files will never exist again. That is why the document demands explicit commit evidence.
And explicit commit evidence means utilizing cryptographic hashes, right?
Yes. The build system is only allowed to pull source code tied to a specific universally verifiable alphanumeric hash in the central Git repository. A hash is a unique digital fingerprint of the code at an exact moment in time.
So by demanding the hash, it eliminates the human variable and the ambient ghosts entirely. The machine is only allowed to build what is mathematically recorded in the vault.
Exactly. This obsession with verifiable evidence ties directly into the core theme of Wave 3, which is the absolute necessity of hard receipts.
Generating explicitly demanded receipts is the only thing that elevates this process from a mere test to a mathematical proof.
Right. The system isn't allowed to just say, trust me, the build finished. It is required to produce a tangible build receipt containing the exact source commit hash and the resulting image artifact IDs.
Let's define image artifact IDs really quickly.
When an application is compiled, it is packaged into a standardized self-contained box called a container image. Every time a new box is created, the system assigns it a unique permanent identification number, the image artifact ID.
So the receipt proves that a specific hash of code resulted in a specific identifiable box.
The chain of custody is unbroken.
Exactly. The system doesn't just say, I deployed the code. It produces a deploy receipt showing the exact Argo synchronization status and the namespace health, meaning it proves the segmented area of the server cluster where the app lives is actively reporting it is healthy.
Right.
It doesn't just say the app is live on the internet. It produces a DNS or live receipt containing the specific Cloudflare routing records and explicit HTTP server response codes.
The system is forced to cross-examine itself and hand the jury the evidence. It has to mathematically prove it didn't cheat to get the right answer.
And the text is utterly ruthless about what invalidates the proof. If a step silently falls back to an alternative method without generating a receipt, the entire proof fails.
Right.
Give me an example of a silent fallback.
Suppose the AMOF engine attempts to build the application on the designated high-speed cloud cluster, but the cluster is temporarily unresponsive.
Okay.
The automation engine, trying to be helpful, silently decides to shift the workload and build the code locally on a backup server instead. It successfully compiles the code and deploys it,
Yeah.
but it never logs the fact that it abandoned the primary cluster. That is a silent fallback. It achieved the goal, but it obscured the method. The proof is voided because the system lied by omission.
It achieved the result, but invalidated the baseline. The document also highlights that requiring broad, unrelated cleanups to finish the run is a failure trigger.
Yes.
Meaning if AMOS gets stuck on step 4 and says, hey, I can finish this deployment, but first I need a human to go manually delete 50 unrelated cache files over in this other directory, the test is considered a failure.
The golden flow must be clean, unencumbered, and entirely self-sufficient.
Now, anyone who has ever worked on a major high-stakes technical project, or honestly, anyone who has ever tried to renovate a house, knows exactly what psychological trap is coming next.
Oh yeah, the temptation.
You are in the middle of running this incredibly rigorous, highly disciplined test. You have the hood open, you are staring at the deep infrastructure code, and out of the corner of your eye, you notice a massive typo in the user interface.
Or you see an old, inefficient database script that could really use a quick refactor.
Right. It is overwhelmingly tempting to just fix a few cosmetic bugs along the way while you already have access to the code. It will only take 5 minutes. I'm already here.
It'll only take 5 minutes are the famous last words of software development. It is the exact mindset that causes multi-million-dollar outages.
And that deeply human temptation brings us to Wave 4, which exists entirely to outlaw that specific impulse. Wave 4 is titled Supporting Hardening, and its primary directive is brutally, wonderfully simple. Operators are instructed to implement only the specific blockers that directly prevent the golden flow from succeeding.
Wave 4 is a masterclass in extreme scope control. The authors recognize the temptation, so they provide a rigid list of explicit exclusions actions that are absolutely unequivocally forbidden during this phase.
Let's read the riot act. What are the do-nots?
Operators are forbidden from undertaking broad UI redesigns. They are forbidden from initiating all ecosystem cleanups. There is to be absolutely no speculative memory engine optimization, no generalized real-time data migrations.
Okay, so what if they hit a real error?
If the AMOF engine hits a genuine error in the build backend, the engineers are instructed to close only the minimum gap required to generate the receipt and get the pipeline moving again. They are explicitly forbidden from rewriting the entire build engine just because they found a flaw.
I look at this like fixing a catastrophic leak in a military submarine.
Yeah.
You are hundreds of feet underwater, the alarms are blaring, and freezing ocean water is spraying in from a broken pressure seal on the hull.
Right. Total crisis.
You run over to fix the seal, and you notice that the paint on the galley walls next to the leak is peeling, and it looks really ugly.
You do not stop to scrape and repaint the galley walls.
You fix the pressure seal, you stop the lethal intake of water, and you move on. Deciding to repaint the walls while the submarine is actively taking on water is not just a distraction, it is a fatal error in prioritization.
That is a highly accurate mechanical analogy. And to extend it further, repainting the walls introduces entirely new, uncalculated variables into a fragile system.
What do you mean?
What if the paint fumes interact negatively with the submarine's air scrubbers?
Right.
What if you accidentally unplug a vital depth sensor while reaching up to paint the ceiling?
Ah, I see.
In software engineering, deciding to just quickly fix a UI bug might accidentally alter a shared dependency library that the AMOF delivery engine silently relies upon. You could invalidate the entire golden baseline proof that you just spent 3 agonizing waves setting up, all because you wanted to change the font color on a button.
So wave 4 enforces absolute tunnel vision. You fix the flow, you generate the receipts, and you touch absolutely nothing else.
Exactly.
And once you have achieved that, once the GMOB application has flawlessly passed the end-to-end golden proof, generated every hard receipt without a single silent fallback, and mathematically proven that the AMOF delivery engine actually functions in a sterile, perfectly constrained environment, then what happens? Do we finally hit the master switch?
We still do not hit the master switch,
Wow.
but you are finally permitted to look at the rest of the fleet. You enter Wave 5, the ecosystem rollout matrix.
So the remaining applications in the company's portfolio are finally queued up, but they aren't rolled out randomly. They are sequenced based on how closely their architecture matches the golden pattern that GMD just proved.
Correct. The document forces operators to classify every remaining application into 3 distinct integration categories.
What's the first one?
The first category is same pattern. These are downstream applications that are architecturally identical to the GMD template. Because they are structurally identical, you can confidently use the exact same JSON delivery contract. You simply swap out the ecosystem name variable, and the target host URL and AMOF will handle it flawlessly.
That represents easy, highly predictable scaling. You prove the mechanism, now you just feed it identical materials. What is the second category in the matrix?
The second category is same pattern with minor overrides. This is precisely where the hotshot application lands.
Okay, the one we talked about earlier.
Right. Fundamentally utilizes the same deployment mechanism as GMD. But if you recall, hotshot contains those highly sensitive production.env guardrails and secret data keys.
So it's dangerous.
Right. Because of that structural difference, the JSON contract requires explicit manual overrides to handle the injection of those secrets securely.
To go back to the train analogy, it's the exact same locomotive and the exact same tracks, but the train is carrying highly hazardous cargo. You don't need to rebuild the train, but you do need to add specialized shock absorbers to the cargo car before you let it leave the station.
Exactly. It requires careful, documented modification. And the final category of the matrix is the most demanding. The document literally refers to it as the special snowflake.
I love that a highly technical, rigorous engineering strategy document officially uses the term special snowflake.
It is an industry standard term for a reason. A special snowflake is an application that deviates so far from the canonical standard that it requires a completely bespoke delivery design. And crucially, Amof platform, the core delivery engine itself, is locked into this category.
Because we finally have to address the robotic arm, building the robotic arm.
Yes. Because AF platform is orchestrating the delivery, it inherently lacks the standard Argo synchronization and DNS truth mechanisms of a normal downstream app. It is a completely unique topological entity.
Right.
The matrix dictates that it must be handled with extreme localized care, and it is only allowed to be upgraded after the standard downstream delivery mechanisms have been definitively proven across the rest of the fleet.
The matrix ensures that the act of scaling up isn't based on blind faith or adrenaline. It is calculated, predictable, and firmly rooted in proven patterns.
Exactly.
And once that golden ecosystem is proven and the rest of the fleet is safely queued up and classified in the rollout matrix, we finally arrive at the ultimate objective of Ultraplan 8. The paradigm shift the entire document has been building toward. We reach Wave 6.
Wave 6 is titled the Operating Mode Switch. This is the moment the paradigm fundamentally changes.
This is when the training wheels finally come off. Wave 6 officially declares that primary delivery execution formally moves into the Amof system. And this is perhaps the most massive, but in the entire text, this switch is authorized to happen only after all the rigorous criteria of the previous 5 waves are met, and the mathematical receipts from the GMD proof are absolutely undeniably secured in the vault.
It represents the formal handover of power. The organization is transitioning from a fragile human-driven manual process to a mathematically verified automated engine. And a massive component of this shift involves the explicit demotion of a legacy command system.
Right. The document specifically points out a major casualty in this transition of power. A legacy system or tool known as Cursor is explicitly stripped of its authority. It is removed from its role as the primary manual delivery executor.
Under the old paradigm, Cursor was the default command center. It was the interface where human operators would manually coordinate code builds, aggressively trigger deployment scripts, and manually bump release version numbers. It was the absolute hub for human intervention and conversational commands.
But if Cursor is officially stripped of its primary executor role, what happens to it? I assume they just delete it, right? Tear down the old server to make room for the new one.
Not at all. The engineers behind Ultraplan 8 are highly practical. They don't just discard a powerful tool. They systematically refocus it into a highly specialized secondary role.
Okay, what role is that?
Cursor is demoted, but it becomes the critical bootstrap and emergency repair mechanism. It becomes the manual tool you reach for when Amof itself suffers a catastrophic failure and you need to manually restart the core engine.
It becomes the emergency glass you break when the automation fails.
Exactly.
Yeah.
But it also takes on a secondary, highly focused role. Cursor becomes the designated space for deep, complex code editing and focused implementation after the Amof system opens a diagnostic ticket.
Oh, I see.
If an automated deployment fails, Amof identifies the broken stage and flags the owner. The engineer then uses Cursor to execute the surgical repair.
So the separation of concerns is finally absolute. Cursor is strictly for writing and repairing the code. Amof is strictly for delivering the code. The lanes are no longer blurred.
Right.
And there is a specific, incredibly evocative phrase in this final section of the document that I think brilliantly captures the deep pain of the old way of doing things. The text states that under this new Amof paradigm, a failed deployment run must produce an actionable failure contract rather than requiring the engineer to engage in transcript archaeology.
Transcript archaeology. It is such a visceral, painfully accurate term for anyone who has ever had to debug a complex, interconnected software system under pressure.
I want to paint a picture of this for the listener because understanding the pain of transcript archaeology makes you realize why the strict JSON contract is so revolutionary.
Okay, set the scene.
Let's create a scenario. It's 2 a.m. on a Sunday. A massive complex deployment has just failed catastrophically under the old manual conversational paradigm. The engineer on call, let's go back to our hypothetical engineer Dave, is ripped out of bed by a pager alarm.
Poor Dave.
Right. He logs into the legacy Cursor system to figure out why the deployment failed. What is he actually looking at on his screen?
He is staring at a sprawling, chaotic, completely unstructured wall of text. He is looking at the combined terminal output of perhaps 10 different deployment scripts that were running simultaneously. It is thousands upon thousands of lines of system warnings, automated chat prompts, ambiguous error codes, and server memory dumps.
It's just digital noise.
Exactly. And to figure out what actually broke the system, Dave has to become an archaeologist. He has to manually scroll back through the strata of this massive transcript, trying to construct a mental timeline of the failure.
Wow.
He has to guess which yellow warning message was just a harmless red herring, and which obscure error code was the fatal blow that brought the system down. It takes hours of frantic searching. It relies entirely on his human intuition, his past experience with the quirks of the system, and his ability to hold thousands of variables in his head at once.
It sounds miserable.
It is incredibly stressful, and it is prone to massive human error.
But when we switch to the AMO paradigm, driven entirely by that strict, unyielding JSON delivery contract from Wave 2, how does that 2 AM failure scenario change?
With the JSON contract, the failure state is no longer a chaotic accident. It is a meticulously engineered outcome. If the deployment fails at 2 a.m., AMOF does not spit out a novel of terminal logs. It halts execution immediately as mandated, and it returns a highly structured mathematical failure envelope.
It hands Dave a receipt of the failure.
Yes, the JSON contract updates to explicitly state execution halted. I encountered a fail status at step 4 deploy. The designated owner of this failure is the Argo CD synchronization component. The specific mechanical reason is a timeout error on the namespace synchronization exceeding the 45-second constraint. This is a non-retriable error based on the acceptance criteria. Attached is the cryptographic hash of the exact system state right before the failure occurred.
It doesn't ask the engineer to dig through the dirt to find the broken puzzle piece. It elegantly hands the engineer the exact piece of the puzzle that failed, highlights the broken edge, and provides the exact coordinates of where it belongs.
It is a profound night and day shift in operational maturity. You move from exhausted developers and digging through chaotic logs in the dark, hoping to guess the right answer, to an automated system that objectively and explicitly categorizes its own failure states.
It is absolute clarity born out of extreme rigidity. So as we reach the end of this journey, let's pull all of these complex threads together and synthesize the overarching philosophy of Ultraplan 8. What we have uncovered here today is a document that champions an extreme, almost painful level of organizational discipline.
It really does.
It is a total unapologetic rejection of the flashy, simultaneous rip-and-replace fleet rollout that the tech industry is so heavily addicted to. Instead of fireworks, it forces an organization to endure a slow, methodical, ruthlessly validated golden proof using a single, incredibly boring application template GMD.
It champions the clarity of structured rigid JSON contracts over the false ease of conversational vagueness. It demands hard, mathematical, verifiable receipts over undocumented assumptions and the ghosts of ambient state. And perhaps most importantly, in Wave 0, it forces you to humbly acknowledge and map the hidden truth of your messy systems before you ever have the arrogance to attempt to change them.
In a world and an industry that is utterly obsessed with doing everything faster, bigger, and all at once, there is immense, undeniable power in doing exactly what Ultraplan 8 prescribes: slowing down,
Acknowledging that local drift is a reality of human behavior.
establishing absolute truth, and demanding mathematical proof of a single perfect execution before you ever allow yourself the luxury of scaling.
It is the difficult discipline to not repaint the galley walls while you are trying to fix the lethal leak in the submarine. Restraint is how you build systems that actually survive contact with reality.
Which leaves us with a final provocative thought to mull over. The entire premise of Ultraplan 8 requires the automation, the incredibly powerful Amof system to produce hard receipts at every single step to mathematically prove that it didn't cheat.
It is strictly forbidden from relying on the ambient state of a local machine.
And it is explicitly outlawed from quietly falling back and fixing things behind the scenes without logging the method. If our ultimate goal, whether we are building cloud infrastructure, managing a corporate logistics team, or just trying to organize our own personal lives, is to build autonomous systems and processes that we can truly trust, perhaps true trust isn't about the absence of human supervision.
That's a great point.
It's not about just closing our eyes, hitting the master switch, and letting the machine run in the dark. True trust is about building systems that are inherently structurally designed to audit themselves and hand us the receipt.
I love that.
So I'll leave you with this question. Think about your own workflows today. Think about the processes you rely on at work, the tasks you try to automate, the daily routines you run on autopilot. How much of your daily workflow is running on undocumented ambient state? How many hidden assumptions are holding your projects together? And if you were suddenly forced to, could your most critical processes survive a strict mathematical audit for hard receipts? Thanks for joining us on this deep dive.